In this video, I will explain you how to solve the multi-stage graph. So the objective of the problem is to find out the shortest path between source and destination. In this particular slide, you can see that there is vertex 1 as source and vertex 12 as destination. And the objective is to find out the shortest path between source and destination, which will cover one vertex of each stage. So there are 5 stages. So the path will consist of vertex 1 and vertex 12, and there will be 3 intermediate vertices which will belong to stage 2, stage 3, and stage 4. The objective or the motivation to solve this problem is to travel from vertex 1 to vertex 12 in minimum distance. The algorithm which we are discussing here is called as backward algorithm, and the formulation for backward algorithm goes like this. We are calculating the cost for traveling between source and destination, and since we are basically naming this algorithm as backward algorithm, we are taking this array as B cost. B stands for backward here. So there are two variables which are being used here. One is I and one is J. I represents stage and J represents the vertex which belongs to the stage. For example, if I talk about B cost of 3, 6, then 3 is the stage and 6 represents the vertex present at that stage. For example, if you take this graph, then this is stage 3, and in this stage 3, there is a vertex 6. So this will be termed as B cost of stage 3 vertex 6. If I take this vertex, then I will take it as B cost of stage 4 vertex 10. It is the basis idea is you will be finally traveling to B cost of 5, 12. That is stage 5 and vertex 12. And the initial or the starting vertex will be B cost of 1, 1. That is stage 1 and vertex 1. So moving forward in the concept, when we are talking about multi-stage graph, if you are traveling to vertex 6, then the possible travel will be only through the vertices of previous stage. For example, if you take the graph again, then previous stage is 2, and vertices which are possibly used to travel to vertex 6 will be either 2, 3, 4, or 5. Okay. Here I am taking all the possibilities, but all the possibilities will not be used in the calculation, because you can see that vertex 4 is not connected to 6 and 5 is also not connected to 6. So there are only two possibilities. One is vertex 2 and one is vertex 3. Hence, we will have to take the help of vertex 2, which is present at stage 2, and we'll have to take the help of vertex 3, which is also present at stage 2. Why we are talking about stage 2? Because we are trying to reach to a vertex of stage 3. Hence, vertex of stage 2 will be used and suitable vertex. what is L? L represents the set of vertices which belongs to the stage I minus 1. L represents what? State of vertices which belongs to stage I minus 1 such that there is a connectivity between L and J. What is J? J is the vertex which we want to reach. Hence, we must reach to a vertex L which is at stage I minus 1 and which has connectivity to vertex J. Is it clear? One more time. If you want to travel to J, then find out what are the vertices which are present at stage I minus 1. J is present at stage I. So find out the vertices which are present at stage I minus 1 which has connectivity to J. So the vertices which has connection to J will be called as L, and once we are able to find L, then we will use the cos to travel from L to J. So this is a very simple idea wherein we are talking about reaching to a vertex of stage I from the vertices of stage I minus 1 using the cost to travel. So stage I, if it is, let's say, 4, and if the vertex is 10, so again, if I go backward, 4, 10, then 10 is reachable from 6, 10 is reachable from 7, and 10 is reachable from 8. So for reaching to 10, I will be using, so 10 is present at S4. I can use the vertices of S3 as 6, 7, 8. If you look at another vertex 11, then 11 can be reached from S3 only using vertex 8. And in this way, we'll keep on computing the distances using the minimum distances and finding out the best path to travel between source and destination. I hope you understood the idea up to this point. I will be continuing in the next video the complete calculation for the distance between source and destination.